Hello 108 students, Mr. McHugh back here with you on section 6.3 special factoring. We're going to go ahead and wrap this up on page 2. We've got a fair amount to cover here, so let's get going. Example 2 asks you, can you factor this trinomial? And the first hint to help you out here on these is I like this notation. Can you take the square root of the first term? And the answer would be what? Hopefully you're saying yes. Can you take the square root of the second term? And hopefully you're saying yes. The question is, and bring down the sign, can you take 12p first square root times the second square root and double it? Does that match the middle term? And when it does, so you've got 12 times 5 is 60 times 2 is 120. You do match it. So the answer is yes, you match the middle term. You can directly go to the shortcut, which is give yourself a parentheses, drop the first square root, drop the sign, drop the third square root, and take that binomial and square it. Okay, one last example of that. Now, not the last example. Let's go down and look at this one. Now, what happens if you don't get that matching of the middle term? Well, here's an example here to look at. So I would ask myself, I'm coming over here, wish I had a little more room. Can you take the square root of the first term? And you say yes. Can you take the square root of 49m squared? And you're going to say 7m quantity squared. Now the question is, can you take 2m times 7m, double it? Does that equal 20? Oh, I forgot, that's an n. Oh, excuse me, class, that's an n. Okay, that's an n. So can you double it and come up with the middle term? So 2 times 7 is 14 times 2 is 28 mn. That does not equal the middle term, therefore cannot be factored. Okay, there's an example there. Now you could turn around, spend a lot of time doing reverse FOIL, trying to find out the parentheses, but that's what you're going to find out. Okay, so let's kind of keep cruising here. Let's look at example D. They give you 4 terms and they ask you to factor it. Your big hint should be when you see 4 terms, you've got to do groupings. Group the first 2 terms, group the second 2 terms, and then look at them individually. Okay, so I look at this and I go, ooh, it's always rule number 1. Look for a GCF. I see an m squared or an m, I pull it out. I'm left with m minus 8. M times m is m squared, m minus 8 is minus 16. M times the quantity m minus 8. Now I come over here and I look at this, and what catches my eye? Can I take the square root of the first term? Yes. Can I take the square root of the second term? Yes. Do I have subtraction, the difference? Yes. Write that and write that binomial and multiply it by its conjugate. And when I say conjugate one last time, that means it's the same binomial except the signs are opposite. The subtraction goes to a positive. Okay, so that takes us down to objectives 3 and 4 here, and if you have your books with you, look on page 335 for this guy, and the factoring of the sum of cubes is on page 336. Okay, now what we have here is some memorizations of special factoring, and over the years I've been able to come up with some verbal clues to help you out here so that you don't have to go crazy memorizing these. Now if you look at here in the book and you study these in the purple boxes, they look very similar. Okay, so here's how I handle these. I take the difference or sum of cubes. I follow the exact same verbal steps to get the factoring. So here's what I mean. I'll use this example right here. Now here's the rule. It's all got x's and y's, but here's how it goes. Can you take m cubed minus 8 and do you have the difference of cubes? Meaning, can you take the cube root of the first term? Yes, it's an m. Can you take the cube root of the second term? And the answer is 2. Do you have, and it doesn't matter whether it's addition or subtraction. Okay, so once you have that form, and you might be able to do that mentally, which is fine, drop down the first cube root, drop the sign, drop the second cube root. Does everybody see that? I like using those parentheses in the cubes because that answers the question, what is the cube root? It's inside the parentheses. Drop them down with the sign. Then what you're going to do is follow the pattern. Take the first cube root, square it. Take the second cube root, put it to the end, and square it. And then the middle term is multiply the two cube roots. First cube root times the second, first cube root times the second cube root, or multiply the two cube roots is an easier way to say it. Okay, so let's clean this up a little bit. These don't require a whole lot of work. They require just a little bit of being organized and being patient here. So drop the first binomial is m minus 2, and you're going to multiply that binomial by a trinomial. That's what you got up here in the shortcut rules. A binomial times the trinomial. Okay, so m squared plus 2m plus 4. And you're done. Okay. And a couple notes here. I just happened to notice this. If you have the cube root of x to the 12th, what you end up with is x to the 4th, because x to the 4th times x to the 4th times x to the 4th would equal x to the 12th. Remember, you add the exponents. Another shortcut way here is when you see, we did this in chapter 8, when you've got a cube root and the exponent inside, take 12 divided by 3, and if it comes out a whole number, you can do it. Okay, such as the cube root of x to the 9th is x to the 3rd, and that's because 9 divided by 3 is 3. Okay, so once you've got this working with the difference of cubes, the sum of cubes is the same process. Now, the way I like to learn it and teach it is take this example right here, r cubed plus 27. Do you have the cube root of the first term? The answer is yes, r. Do you have the cube root of the second term? The answer is 3. Okay, once you've written that format, and I think that's worth taking that step to do it, drop the first cube root, which is r, drop the sign, same word you said last time, but this time it's a positive. Drop the second cube root, write it as a binomial, and then multiply it by the trinomial, which is to take the first cube root, square it. Take the second cube root, which is 3 squared, second cube root, which is 3, square it, which is 9. That's where the 9 came from. Then multiply the two cube roots. R times 3 is 3r, and I forgot to say this, class, whatever the sign is of the binomial, switch it. I apologize for that. Make sure you take the sign of the binomial and switch it. Look what I did over here. I forgot to say this. You drop down to minus, then over here you take the minus and switch it from a negative to a positive. This always ends up B. These are always positives over here, and that's because you're squaring a number. Whether it's negative or positive and you square it, you still get that. Okay, so hopefully those words are helping you here. I'm hoping it'll take out memorizing. You can write these on your reference sheets if you want, but hopefully you do these enough times you'll feel comfortable that you will have already had oops, sorry, I don't want to do that again. I always hit that scroll bar. The difference or sums of cubes, if you say it in words and translate it into sentence translation, it's not bad. Okay, hey, let's do one more here and we'll wrap this up. Example 4D says 3x cubed plus 192. I see the cubing in there and I go, ooh, I don't know if I could take the cube root of 192. However, rule number 1, always look for a GCF, which is a 3. You pull it out. What are you left with? X cubed plus 64. Now what you do, you bring the 3 down. Do you have the sum of cubes? Can you take the cube root of x cubed? The answer is yes. Can you take the cube root of 64? And the answer is yes. So you've matched the form. Okay, now from there we go back up here to my my notes here. Now remember that 3, you did that GCF, you just keep bringing it down. Now here's what you do. The 3 is the GCF. Now write your binomial. Write the binomial. Drop down. I like to work vertical here, so let me get this. Drop down the first cube root, drop the sign, drop the second cube root into the binomial, and then multiply it by the first binomial squared. Middle term is to multiply x times 4. So that would give you a positive, and minus, excuse me, switch the sign, don't forget that. Positive goes to a negative. That you have to remember. That's the hardest part to remember. Finally, take the second term, the second cube root, and square it. So there's the work, there's the results. The only thing I did different was I cleaned it up from x squared, x took out the parentheses, 4 squared is 16. And there's your final answer. Okay, so we've done it here. This page was just a tad longer than I usually like to go, but we get to check this off for section 6.3, and we have taken care of special factoring. Okay, Mr. McHugh, going to sign off here for now. When I see you next video, we will start section 6.4, and we'll be doing a general approach to factoring. Okay, take care, and I'll see you then. Bye.